Okay, here's the problem from slide 14. Now again, we first want to consider what degree this polynomial is, and so if we trace the graph, we see we go down, up, and down again. So 3 directions means third degree, or we look at the number of turns, 1, 2 turns, 1 less than the number of degrees, so 3 degrees. And then we follow the steps over here. So x-intercepts. We see an x-intercept at -2, and we see an x-intercept at 1. And if we're going to write this in factored form, that would mean that we would have x plus 2 times x minus 1. Now here's where the degrees become important, because if it's a third degree polynomial, we need to have 3 x's being multiplied, and we only have 2 here. So we want to pay attention to this first root that bounces off the x-axis. That's actually a double root, which means that is going to be squared. Okay, and so our equation would be y equals something times that. A point on the graph. Looks like this is a point right here at the point 0, 8. Now remember, it's only the x-intercepts that are important for writing the equation. The y-intercept here is perfectly fine to use as a point to plug in. You'd never want to pick an x-intercept to plug in, though, because that won't work. So we're going to plug this in. 8 is going to go in place of y, so we're going to have 8 equals a times 0 is going to go in place of x. 0 plus 2 squared times 0 minus 1. 0 plus 2 is 2. 2 squared is 4 times -1. So we have 8 equals a times -4. We're going to divide by -4, which means a equals -2. And then we just write our final equation. Y equals -2 times x plus 2, the quantity squared, times x minus 1. And you can always check your work by plugging that into decimals and seeing if you get the same graph.